Hello, welcome back to another episode of Measurement in a Minute. I'm your host, 𝗦𝗧𝗔𝗬𝗓 with Lakeside Process Controls. Today's episode, we're continuing our discussion around Rosemount's magnetic flow meter technologies. In particular, we've been talking through slurry applications and the difficulty with overcoming signal to noise ratios. The reality is there's another challenge in these applications, and it's dealing with erratic or high variance in the raw data that comes from a magnetic flow meter. So let's walk through an example, and I'll show you how this was traditionally handled versus how we now handle this today. So in this example, we have a Rosemount magnetic flow meter that's upstream of a Fisher control valve, and we have a flow control loop. And ultimately, we're trying to control a specific flow rate out of this control valve to that downstream process. Maybe it's to a reactor, let's say. The reality is, the actual flow rate to your process does change with time. And if we had, a magical way to see what that actual flow rate was, let's pretend that this is what it is. And it's, around some sort of midpoint, drops, comes back to that midpoint. Maybe that's your average flow rates. The reality is, through the eyes of the mag meter, it is a lot more erratic of a measurement, right? And this is really difficult to control off of. So naturally, or I should say traditionally, we thought to dampen this, right? Let's add a 2, 3, maybe a 4-second dampening, which is really just like taking an average. And now we have a nice stable measurement that we can then use as the input to control this valve. The challenge is we've added a delay in this measurement. So if you see at the end of the graph, or the end of really the x-axis there, it is still below that midpoint, but we know the actual flow rates returned back to that midpoint. So that's actually going to have an impact on the process that we might not even realize. And so the control valve, it has nice smooth travel, but you'll notice maybe the control valve is opened a little bit more at the end of this x-axis here than maybe it should have. And so the result is actually we might be letting too much product through this valve, and instead of having a nice, consistent, even downstream process flow rate, we actually now have an uptick because of this damping. So that's the challenge with dampening. I'm going to show you another way though, and it's through what we call adaptive signal processing. Okay, so we add signal processing to it, and we'll get into the nuances in the next video of what we're actually doing here. But now you'll see that when the end of the x-axis, we've gotten back to that midpoint. Okay, so what this means is the control valve opens, or maybe opens a little bit more, and then closes, or closes a little bit more. And as a result, we have a nice consistent downstream flow rate to our reactor, which is ultimately what we want from an efficiency, safety, and really just overall control standpoint. Should you have any questions about Rosemount's magnetic flow meters or any other of our technologies, please reach out using the QR code to my left. Thanks and have a great day.